So let's do some examples where we try to evaluate the discrete time Fourier transform of some periodic signals. So this is a simple example of a cosine which has a frequency of 2 pi by 5, and we're required to find the DTFT for the signal within the interval from minus pi to pi. This could be anywhere, but this problem statement says we just need to determine from minus pi to pi. And the way we go about this is just by a simple application of Euler's identity. So we break it down into complex exponentials. I mean, you could do it with the Fourier series, I mean, which is exactly the same as well. So this is half e raised to power j 2 pi by 5n plus half e raised to power minus j 2 pi by 5n. And then I just analyze each and every one, both of these complex exponentials individually, and I figure out that what the Fourier transform of e raised to power j 2 pi by 5n is. So if I take the Fourier transform for this from our previous discussions, this is just going to be a train of impulses in the frequency domain where the first impulse is going to be at 2 pi by 5. So let's say if this is the frequency domain, and because we're only interested in the Fourier transform between minus pi and pi, so let's say this is minus pi and this is plus pi. So fortunately, 2 pi by 5 resides within this interval. So let's say this is 0. So 2 pi by 5 is approximately going to be somewhere over here. And the height for this is going to be 2 pi times 1 by 2, which is 1 by 2 appears here. So this is just going to be height of pi. Similarly, I can carry out a similar analysis for the other complex exponential e to the power minus j 2 pi by 5n, and the Fourier transform for this is going to be a single impulse, but where that single impulse is now going to reside. So this is 2 pi by 5, and this impulse is going to reside at minus 2 pi by 5. So this is where the impulse is going to reside, and the height, of course, is going to be pi once again. And this is minus 2 pi by 5, and this is 0. And therefore, I just applied linearity. So x of n will have a Fourier transform which looks like this. So this is minus pi and this is plus pi. There's an impulse here at 2 pi by 5. 2 pi by 5 is, there's an impulse here at 2 pi by 5. There's another impulse here at minus 2 pi by 5. The height over here is pi. The height over here is pi as well. This is 2 pi by 5 and this is minus 2 pi by 5. Mind you, I've just depicted the Fourier transform only over the interval between minus pi and plus pi, with the implicit understanding that this Fourier transform repeats itself periodically over the entire frequency axis from minus infinity to plus infinity. And mathematically, if I were to write this, I'd say that x of e raised to power j omega is actually equal to pi times delta of pi times delta of omega minus 2 pi by 5 plus pi times delta omega plus 2 pi by 5. And of course, this is only applicable for minus pi to omega to pi, only over this interval, with once again the implicit understanding that this repeats itself periodically over the frequency axis. Now, what if, so let me consider another example in which I just slightly change the frequency. I ask you to determine the same DTFT, but rather for a cosine which has a frequency of 6 pi by 5. And you're required to determine the DTFT once again for the same interval for minus pi is less than omega is less than pi. And this should be pretty straightforward as well. The only difference being that when 6 pi by 5 is going to the Fourier transform for that is going to correspond to an impulse, but that impulse is not 6 pi by 5 does not reside in the interval minus pi to plus pi. So so x of n is half e raised to power j 6 pi by 5n plus half e raised to power minus j 6 pi by 5n. So if I just look at what the Fourier transform of half e raised to power j 6 pi by 5n is, I compute the Fourier transform in the Fourier domain, and I see that the impulse is going to reside at 6 pi by 5. Well, that 6 pi by 5 is that 6 pi by 5 is slightly bigger than pi, right? So what I'm interested in is what the impulse is going to be, where the impulse is going to be within the interval minus pi to pi. And for that, I just find out a copy. I know that this periodically repeats itself. So if it periodically repeats itself, I just find out what the next copy is going to be. So if this difference is 2 pi, so I know that there's going to be an impulse residing over here as well. And this is going to be equal to, this is going to be 6 pi by 5 minus 2 pi. So this is 10 pi. So this is minus 4 pi by 5. Right, so this is where the impulse is going to be within the interval minus pi to plus pi. Similarly, what about the half e raised to power minus j 6 pi by 5? And what about the Fourier transform for this? And the Fourier transform for this is going to be an impulse which resides at minus 6 pi by 5, which is just slightly out of the interval that I'm interested in. But in order for me to find a copy which is inside the interval I'm interested in, I just find out once again. So this is going to be 2 pi, and this is where the next copy is going to reside at, which is here. This frequency is going to be minus 6 pi by 5 plus 2 pi, which turns out to be equal to 4 pi by 5. So therefore, my conclusion therefore is that the Fourier transform of x of n in this particular example is going to be within the interval minus pi to pi are going to be two impulses. One of them, so if this is pi and this is minus pi, one of the impulse is going to be at 4 pi by 5, and the other one is going to be at minus 4 pi by 5. And so x of e raised to power j omega is really, and the height, of course, for all of these impulses is going to be pi, the same as before. So this is pi, pi here, and pi here. So this is pi delta of omega minus 4 pi by 5 plus pi delta omega plus 4 pi by 5. And of course, this this only applies for the interval minus pi to omega less than equal to omega is less than pi, right? And it periodically repeats itself outside of this interval as well. Now, one of the other ways that you could have immediately done it was that and this actually tells you that what if I had taken another signal, which is x of n, which is cosine 4 pi by 5n, and you compute the Fourier transform for this, you would have found out that the Fourier transform for this actually would have turned out exactly to be the same as this over here. So does that mean that cosine 4 pi by 5, I mean, that would actually imply that cosine 4 pi by 5 is actually equal to cosine 6 pi by 5. And this is something that I want you to check out. That actually turns out to be true. Go ahead and verify it yourself.